Welcome to this Wood Solutions campus presentation on selling and supplying timber and wood products that are fit for a customer's intended purpose or application. Selling a fit-for-purpose product requires two things. The first is knowing what the product application is. This will largely establish the product's performance requirements, that is, what it has to do to perform satisfactorily. This first point is discussed in other presentations in this course. The second thing is knowing the performance that the product can reliably deliver. This presentation focuses on this second point and provides some background on what products of different types can deliver. This is critical to ensuring that the sold products are fit for purpose. A product is fit for purpose if it does the job that the customer wants or was told that it would do, and it does it for an expected period of time. To express this more technically, the supplied products must satisfy the application's performance requirements efficiently. Timber and wood products are often installed as part of a system, such as a wall or flooring system, that can have a coating or finishes and can be installed with fixings. The customer will expect that the product installed in the system will be fit for purpose. Given this, interactions between the timber and other parts of the system may be important, and the performance of each has to be considered to ensure that all the parts work together. Timber is available for use in a range of different products. Each product has its own characteristics and use in design and construction. Commonly available products include timber rounds, solid sawn and moulded timber, ply and laminated veneer lumber or LVL, other engineered wood products, medium density fiberboard or MDF and particle boards, glue laminated timber or glulam, nail plated products and recycled material. There are simply too many diverse timbers and wood products available to cover all of them here in adequate detail. More information is available in the Wood Solution campus course on timber and wood products. This presentation can only cover the general principles, and there will always be exceptions. There are several key factors that separate how timber products perform, and we will discuss these in line with the key performance requirements listed here. The first key performance requirement is compliance with regulations and standards. This is critical, especially for structural applications. Because of this, thorough processes exist for ensuring that structural timber products are suitably graded and used intelligently. The next two performance requirements, resistance to exposure outside and coping with moisture content change, can be grouped. While they are quite different, they have a lot in common because they deal with the way timber interacts with water. These interactions lead to a wide range of problems for businesses. The last two, resistance to wear and tear and satisfying special market conditions, are both important for specific applications but are relatively easy to address if due care is taken. Each of these will be discussed in greater detail in other videos in this course. However, due to the problems that they cause, requirements for resistance to exposure outside and coping with moisture content changed are discussed further below. The common factor in a timber product's resistance to exposure outside and its ability to cope with moisture content change is the presence of water, either as rain, as moisture in the ground or in a wet area, or in the air in parts of a building. Timber is a hygroscopic material. This means in service it will take up or lose moisture to be in equilibrium with the surrounding environment, and its dimensions will change as it does so. As it absorbs moisture, the timber swells. As it loses moisture, it shrinks. This swelling and shrinkage is often not even, so the boards can distort. Timber is also a biodegradable material. Persistently high moisture levels in the timber can lead to decay, and the element may eventually break down. These effects impact all timber products, so the material's response to moisture is important for its short-term stability and its long-term survival. It is also important in how it is installed as part of a system. Some timber products can resist water and its impacts for an extended period. Durable sawn timber, treated timbers and external plywoods are examples of these products. Some products resist water satisfactorily for a normal construction period, but are really meant to be inside away from moisture. Their resistance to moisture is only short term. Normal structural ply, wall framing and truss products are examples of these types. These products will stand being wet on a construction site for several months, but will start to deteriorate if they are in a high moisture environment for a long period of time. Some products have very little resistance to moisture and can deteriorate very quickly in high moisture conditions. MDF and normal particle board, both common in joinery, are examples of these products.
Architects want to sometimes, it's not that common, but it's scary when it happens, they want to use the veneer on an exterior application such as a door, yep, or an open lobby, and decorative veneer should not be used in the exterior for several reasons. Big changes in moisture content make the substrate move around with moisture change. That can crack the veneer surface. The exposure to sunlight is a shocking thing for veneer. It doesn't matter how good the coating is. Mm-hmm. The effect of the UV on the timber underneath degrades the timber and the coating will just fall off. It's wood on exterior goes grey. Once something's gone grey, the coating's gone. It's great for solid timber that's durable, looks beautiful with veneer. It's only 0.6 millimetres thick. It basically cracks up, shrinks, expands, develops cracks, and the whole thing falls off. No matter how good the glue and coating is, decorative veneer is not suitable for exterior use. It's not suitable for use even in protected exterior. So a door at the back of an open air lobby, I would avoid using timber veneer.
Timber movement through a change in moisture content is entirely predictable, and building systems need to accommodate it. Good installation practice attempts to moderate the potential for moisture content change and allows for it to occur acceptably. Poor installation practice often leads to problems as changes in moisture content are not controlled and inadequate allowances are made to accommodate for it.
Subfloors.
Yep.
I've seen a black butt floor because the subfloor space was compromised, mm-hmm, where it expanded so much. There was 80 mil boards, there was over 120 boards. Each board had expanded by 1 mil, so that's 5 inches or 120 mil of expansion. Mm-hmm. That pushed into the frame. Not only it humped up, but pushed into the brick veneer and pushed the bricks out about 30 mil.
Timber can resist hazards by its natural durability. That is, its natural resistance to fungus and insect attack, or through the use of applied treatments. Durability ratings for the untreated heartwood of timber species are available and indicate the material's resistance to specific biological hazards. AS 5604 Timber Natural Durability lists these ratings and provides guidance in ensuring a timber's suitability for its intended use. It is important to note that these ratings do not relate to the timber's capacity to resist weathering, dimensional change due to moisture, other environmental hazards, or human influences. The intensity of treatment and its effectiveness in different types of wood varies. It is important to note that while a material may be treated, it may not be treated sufficiently for some applications, or be treated evenly or all the way through.
Natural durability ratings, but being familiar with AS 5604, I think is very important, because then you can see what products that are available on the market and whether it's going to fit the bill for that particular job. Treatments. Just because timber is, particularly radiata pine, is treated doesn't mean to say it'll do any. It will do the job. There are various levels. Particularly here we start at H2, which is the termite treatment. H3, above ground use, for finishing timbers in particular, like a cladding. H4, for non-structural in-ground use. H5 for in-ground structural use. And freshwater applications, and H6, which I don't know if I don't know of a producer that does H6, but that's saltwater immersion.
Yep.
Treated pine sleeper. It's cut about 25mm from the end.
Yep.
You can see so much untreated wood. Here we've got the inactive cells that don't accept treatment. Here we've got the sapwood that does accept the treatment. That at the end it looks perfectly treated. That far in it isn't treated. People should be aware of that when they use it in their products, particularly in structural circumstances, which we don't advocate.
In summary, selling a fit-for-purpose product for an application requires knowing what the product application is and the performance that the product can reliably deliver. The customer will expect that timber and wood products installed as part of a system will be fit for purpose. Timber is available in a diverse range of species and products. Each product has its own characteristics and use in construction. Timber is a hygroscopic material and it's biodegradable. Some timber and wood products resist water and its impacts for extended periods. Others resist water satisfactorily for a normal construction period but are really intended for inside use, while others have very little resistance to moisture and deteriorate quickly.